I welcome you back to Global Education Zone, and today we'll be dealing with, in data processing, dealing with an important topic known as data model. Now, in our present day, we store data, right? We know that computers store data and they process data as information. Now, those information they are stored in those computers as information, right? They are stored in different forms. They are stored in document form. They are stored in different form, and those forms of data are known as file extensions. So a file extension is just like when you can store food in a bag, you can store food in a container, you can store food inside a cylinder, you can store food inside different places, different physical structures. So in a computer like manner, data can be stored in different containers, and those containers they are different and they are used in data models. So a data models is basically a model, and a model is just when you see someone pose as a model is like a representation of something, something that stands for the whole different instances of something. And then when we dive deeper into this topic, we will know more about data models. But then let's know what data modeling is. Data modeling is the process of structuring and organizing data models or data. Now, you know that data are raw and unorganized features, right? Now, before data is converted into information, it has to be structured and organized. Now, when data is structured and organized, and even after it's structured and organized, there has to be data modeling. And data modeling occurs to organize information. Even when your computer produces information, that information still needs to be structured. And by structure, I mean the way the information is arranged. I mean the way the information builds upon each other. And data structure is related to data relationship between data. And then we have organization, the way the data are aligned, the way they are arranged together, how they are organized. So a data model is basically they are structured data for storage in data management system. So they are structured already. So they serve as models from other data. Now in our world, there are different data. There are different there are many numerous data banks where you can get data. You can get data from Google, right? Now Google is a search engine. Google organizes data into packets like this. When you visit the search engine, you are basically connecting to a server, right? And that server also stores data, and that data has to be organized. That is in every unit of our society today, which is computerized, and with digitization, data models cannot be dispensable. So data models is very important for you to understand. Now let's go to the concept of data models. Now there are two concepts. We have data structure, and data structure refers to two very different things. A data structure is basically the structure of the data within a given domain, and by implication, the underlying structure of the domain itself. So, for example, the structure of data within Google Chrome is in a server, and the structure of data in the server is the way the data will appear when you search Google as your search result. So basically, that is the implication of data structure. Now we have data organization. It's just like data structure, but structure is basically how the data stands. How much space is between the data? Where is the data located? Which data is beside each other data? Which data are closer together? How many groups of data do we have? That is what we have structure. Then under organization is just like a function of structure. When you have a poor structure, you can never have a good organization. You understand? So even if you have a good organization with a poor structure, your data will still be difficult to understand. So the aim of data modeling is to make the data and computer is to make computer organization of data easy for us. And even those that have laptops, even when we talk about the hard disks, the data on the hard disk is modeled and is broken down into folders. Hard disk space are modeled and fragmented. We'll talk about that in a later video, but that fragmentation is an example of a process in data modeling, and which is also called organization of data. Now we'll talk about approaches in data modeling. There are different approaches in data modeling. There's conceptual data model, there's logical data model, and there's physical data model. Now the conceptual data model identifies the highest level relationship between different entities. Now what are entities? Entities are instances. They are single instances of data. Now if you search for a topic in Google now Google has different data, right, from its server. It has a data bank where it stores all data, and that bank keeps being updated. And there's what we call is a web spider. A web spider is basically a software or a firmware or whatever it is that goes throughout the online and searches for information from even different other servers. So even spiders can also anywhere that's accessible, any web space that's accessible, it can be visited by a web spider, and they collect that data and they organize it into by using data model techniques. So now these data modeling techniques are conceptual data modeling. So when you identify the highest level relationship between data, it's called conceptual data modeling. So basically, you are trying to talk about the highest level. Like now, we are all human beings, right? But when we talk about the highest level of relationship, we talk about families. Families have the highest level of relationship between each other. Then after families, we cannot talk about friends. But we cannot talk about friends before we talk about families. You understand? If you want to consider people for a very, very intimate relationship, if you want to consider people for a very, very intimate and you want to talk to people with your secret, you first talk about your family. You talk to your family first before you talk to your friends. So that's basically what conceptual data modeling. Data modeling is basically in concepts, and those concepts, that's conceptual data modeling. It identifies the highest level of relationship between data. So once it identifies the highest level of relationship, it can be able to organize those data and structure them. Now we have logical data modeling. Logical modeling illustrates the specific entities, attributes, and relationship. Now we'll be talking about entities, attributes, and relationship in a later video. We'll talk about them in detail. But basically, logical data modeling is a basis for the creation of physical data modeling. And logical data modeling is a little bit beyond conceptual data modeling. Now we have what we call developers, right? We have front-end developer and back-end developer. Now conceptual data modeling is just like the front end, while logical modeling is just like the back end. Logical modeling is just like the organization, the day-to-day organization, how that organization is working, how the organization is working, how the computer thinks before it organizes your data. That's what is called your logical data modeling. Then we have physical data modeling. It's an application and all database specific implementation of a logical data model and describes the physical means used to store data. So these are concerned with partitions. Now earlier on I talked about how your CPU is divided into fragments, right? So you cannot see those fragments with your eye, but it's in the software. So most of the concepts used in data modeling, they are within our software, not within our hardware. So even if we have them within our hardware, they are actually little and they are usually related to the firmware and software. Now firmware is the intermediary between your hardware and your software that enables your computer system to work. It is just related to your operating system, but your firmware is more like your hardware. It is the specific parts of your hardware that couples and that works together with your software that controls the hardware. It's like the user interface. So now those are the different types of data modeling. You have conceptual, we have logical, and we have physical. Then we'll talk about types of data model. We have flat models. Flat models are types of models where you use to organize, used by teachers in our schools to organize the scores of students. Now say Ade, Philip, Mary. Then you can organize it as math scores and English scores. I will not call data processing scores now because not everyone offers data processing. You understand? So now, but it's not. I'm not being biased. So now, if Ade scores 15, Mary 20, I mean sorry, Philip 20, Mary 18. English Ade 14, 17, 19. Now this is called a flat data model. Whenever your computer organizes data like this in tables, it's called a flat model. Now this flat model is mostly used in structures like Excel. When you use Microsoft Excel and you want to create a table, all those tables are called flat models. When your computer decides to organize those tables, create formulas and all the rest, it is working on a flat model. Now if we talk about the network model, a network model is basically like when you talk about materials required for the house. We have house, so we have physical and intellectual. So now this network model keeps going on, it keeps branching. So network models for computers keep branching. Like we can talk about the bricklayer, we can talk about the mason, I'll talk about the plumber. Now intellectual, talk about the architect. Architect does not do any work. He just thinks and draws up your building for you. Architects. Now under architects, you can still draw up more and more and more. So now this network model keeps going on, and it's similar to another type of model known as hierarchical model. So hierarchical model is a model just like network model, but each of the branches is simply like network model, but each of the branches don't connect. Now in this model, when they begin to connect, this model right now it's hierarchical, but when they begin to connect, when your bricklayer is also an architect, this connects and this becomes a network model. So you've probably heard of computer networks, right? Computer networks are dense networks where one computer connects to another, and that the last one comes to connect with the first with the middle with the third. So they are just like spider webs. You can't know where it starts and where it ends. But hierarchical models are easier to understand. They don't connect back like this. Now we also talk about relational model, and relational model is a very important important data model we'll be talking about in Microsoft Access in later videos in data processing. Then we also have object relational model. That is also when you relate your entities with your attributes and your relationships. So in summary, we'll talk about the data model, how your data model are the things are standardized data that are stored and used for processing and organization of further data. So I said a model is something you use to like benchmark something else, something you use to serve as an example of something else, right? So those are data models. And then we'll talk about types of data models, which are logical, conceptual, and physical data model. And we have flat model, hierarchical model, network model, relational model, and so on and so forth. And that is a basic and general overview of models. In subsequent video, we'll be going deeper in details on data models. Thank you for watching and good luck.